I will present to you the quality tools XFF Media in chapter 15. Okay, before anything else, we need to know what is quality tools. Quality tools are essential intellectual aids to professionals in various fields. They facilitate continual improvement, problem solving, and effective decision making. Actually, the total quality tools has a seven basic tools, which is the check sheet, histogram, Pareto chart, cause and effect diagram, or the fishbone diagram, scatter diagram, control chart, and flow chart. These tools enable the collection of display of data in ways that aid the comprehension analysis by transforming the data into useful information. Quality tools enhance organization performance and ensure the high quality of standard. Okay. First, this is the first tools that I will present to you, the Pareto chart. The Pareto principle attributed to Wilfredo Pareto emphasizes that a minority of causes lead to majority of problem. Because according to the Pareto principles of Wilfredo Pareto, it has a rule, the 80 and 20%, which is 80% of the total effect cost will spring only about 20% of cost element. Across the diverse domain like product effects and price money distribution, this principle holds true. Due to limited resources, efficient allocation is a crucial for maximum impact. How to make one? First, of course, no, identifying the categories. Next is collecting data. Uh, Calculate the cumulative percentage. I will show to you what is this meaning of cumulative percentage. Plot the chart, analyze and act. This is a sample of the Pareto chart. You can see in the figure one that it has a um, title of this chart is the percentage of total sales by customers. The customer, by the way, is the A, B, C, D, E, and all others. In this statement, 75 of sales from two customers. The customer stated in this diagram, in this picture, is the A and B, which is if they prioritize the E and B, they actually ensure that 75% of the sales comes from these customers. And from from two customers and 90% from three customers. The three customers stated in this is the A, B, and C, which is if they prioritize these three customers, they assure that 90% of the sales on their company. And figure two, you can see actually this is the cumulative lines. And in example two, which is a safe figure two, Swift V12 sales by age group, automotive sales by age group targeting the 26 to 45 age bracket. Why? Because in this cumulative line, you can see that the 73% of buyer each has in a bracket of 36, 45, and 26 and 35. That's why if they have focused the priority of this bracket, they actually ensure that 76 of their buyer, 76% of their buyer. And next is the cascading Pareto chart. I don't want to discuss more about the how to make that because cascading is just a part is that another type of Pareto chart. Cascading Pareto chart involved determine the most significant category in the first chart and creating subsequent chart related to category. Proper cascading can reveal the root cause of the problem efficiently. I will discuss to you right now. In the example, company facing a significant reward cost exceeding $190,000 annually. Initial Pareto chart highlighted that 80% of costs were attributed to just five defect causes. Okay. Uh, as you can see in this chart, you can see that it has a five defects for reward costs, by reward cost. And what you call the high bar is the part failure. And that's the thing that this Pareto, cascading Pareto chart will enter because the part of this part failure will actually have the subsequential chart, which is the this in chart two. The longest bar in Pareto chart accounted for nearly 40% of the cost, indicating a significant issue. By the way, the 190,000 dollars, the 40% of that is the $75,000. Okay, and the level two chart, Pareto has developed the focus of part types of contributing to the failure, which is the failure is the part failure, right? In the previous bar, in the previous figure, and in this part failure, it has a relay, MOSFET, diode type A, diode type B, amp, all others, which is this. And in the figure six, actually, because the relay is the high bar, they actually again create a subsequential to have the what we call to find the root cause of that problem. Because in this relay, because relay failure category, the most the company must be prioritizing to avoid this kind of defects is the open contacts. That's why you need to be cascade, enable you to find the root cause. Okay, next is the cause and effect diagram. Cause and effect diagram, also known as Ishikawa or fishbone diagram, are invaluable tools for the problem solving. I will show to you the figure. And develop by Dr. Ishikawa, this diagram visually represent how various factors affect process outcomes. Illustrate a comprehensive list of factor in PC board factoring process used through brainstorming. Uh, how to make one? Okay, but I will continue to discuss to you here. What is I will summarize this in next slide. How to make one? Okay, identify the problem, of course. Identify the major categories, cores and brainstorming causes, analyze the relationship, and defining root causes. Okay, this is the example of cause and effect diagram. In the figure 7, you can see that all of this is the list of possible causes of solder defects. And how to make the Ishikawa, or Ishikawa or the cause and effect diagram. You can actually This side, you can actually put the cause here, and this side is the head of the fish, which is the effect. This is the, what you call that, this is the figure of cause and effect diagram of the fishbone diagram. Okay, next is the cheat sheet. The third of the 7 quality tools is converting data in useful information. I will summarize this in a in next slide. How to make one. First is define categories. Of course, be mindful with that. Design the sheet, collect data, analyze data, and take action. Okay, I will show to you the example of check sheet. In this side, you can see in the figure 11, this is the summary of shop dimension tolerance result here. And the data in figure 11 are the same as figure 12. The figure 11 shows the columns historical data that before the meaning can extracted by most subjected to hard work at someone's desk. Assuming it goes translate into meaningful information, it will provide still remain invisible to people who could make the best of it, the operators. Okay. In the figurative, you can see that this in this side is the out of limit, which is the because here they actually have the length of shop to be accept, which is the 1.118 and 1.119 is defect, or what we call the out of limit. And the most shaft length are to be what we call produced is the 1.124 here. And you can see here in the figure 14, shaft acceptance 11 and the date 11, they are actually 11 accept 11, but one is rejected. As you can see here, one is what we call that one is rejected. Figure 13, they actually has a reject 11 are accepted and one are is rejected here, as you can see in the figure 12. Okay, next, the histogram. Histogram are utilized to visualize the frequency of occurrence within the datasheet, providing insight into how often certain events or value occur. Two types of commonly associated process, the attributes and the variable data. As you can see here, the attribute data is said to be has or has not, good or bad, pass or fail, accept or reject, conforming or non-conforming. And the variable data, measured variable, like dimension, height, voltage, surface, and etc. Okay, this is example of, by the way, histogram has a part, or what we call it, a version, the histogram and statistics. We know all of us actually know how statistics work. This you can see the calculating the mean. The calculating the mean is actually it's called mu, a summation of x divide the n, where is x is the product of the number and n is the number of the sample product. Calculating the standard deviation, actually, to understand the process, you must know what standard deviation. The formula of standard deviation is here. This sign is called the standard deviation sign, or the sigma. Okay, where d is the deviation and of any unit from the mean and the number of units sampled. I will show to you the example of that and how to um, solve. Okay, this is the first step. First step, this is the graph of histogram, and you need to, in the number two, you need to have the, what we call that, to arrange the data. And the third is you need to uh, multiply the number of read bins to the number of samples, which is result with this. And the total of summation of x is equals to 510, and the n is 100, which is here you can see that mu is equal to summation of x divide n is equals to 510 divide 100. And the result of the mu is 5.1. And here in the fourth step, you actually see the complete division data table. In the 5.1, you can see it result of this 5.1, 4.1, because column 1 minus mu. Okay. Because column 1 has a 1, you need to minus the 5.9 and resolve it is the total of it is D, the column 4. And the deviation squared is column 4 is the column 4 to the power of 2, which is the column 4 is this, and you need to double it or the square root of 2. Then the result is this. And the sum of division squared is column 2. This is the column 2 and times the column 5 here. And the result of this is here, the summation of division squared. And by solving the standard deviation, it is has a formula, right? This is the formula. You can transpose it to 2 to 1, which is this, divide 99, because the 99 is here. And 100 minus 1 is 99. 2.22 is the result. The result is this is 1.49 is called the root means the square division. Here you can see that the summation is equals to 1.49. The 2 times the sigma is a 2.99, and you can see the result of it. And this value is into the figure 15 to create a figure 18 here. The mu minus 1 sigma is equals to 5.1 minus 1.49 here. Okay. And the result of this is here. You can show that 1.57 example, the 9.57 here, the 0.63 here. Here you can see this. You can actually plot that here. Okay, next is the of histogram. Shape of histogram normally dispersion represent a symmetrical bell curve A and B. Here is skewed distribution. Skewed left is the C here, or right D here, indicating the process not centered. Bimodal distribution. Two distinct peaks, potentially from different batches of input material E here. Two input. And data discarding sample discarded below or above set limit F, indicating the 100% ins inspection F. Where's the F here? Histogram depends on the number of sample intervals used for data representation. Okay. Next is the scatter diagram. Scatter diagram are tools used to determine the correct correlation between two variables. As you can see here, in the figure 23, that if this is the form of scatter diagram, it says that here you see this, the diagram is strong positive correlation in A, and B is a weak negative correlation, and the C is no correlation. And in the figure 14, scatter diagram demonstrate the correlation between conveyor speed of solder quality, suggesting the optimal speed of minimum defects here. Okay, next is the run chart. Run chart track output result of over time, providing visual, also known as trade chart. They are used x-axis to highlight performance. Actually, this figure 26, the data of this is how the pen defects slow down. Like the number of pen goes down, like for 3 until it gets to one defects or 1% defects in 21 days. Okay, next is the control chart. Control chart developed by Dr. Walter Schwarzschild in 1920s to distinguish between special causes and common causes of variation in processes. By the way, this chart, the basic control chart, is the thing that you need to have. By the what we call that, you need to control, because if your process average will hit the upper control limit and the lower control limit, it's not said that your process, your quality are being stable, like your defect are being stable after, because the run chart is the first step, and after that the control chart will goes take over that to maintain the the number of defects. Okay, other tools is the 5S, which is the 5S is also known as 5S is considered essential to continual improvement in organization. Yuki Hirano, authors of Five Pillars of Visual Workplace, emphasizes the importance of 5S, claiming that successful implementation is a crucial for integration the large-scale change. 5S consists of five principles: the sort, set, in order, shine, standard, and sustain. It is believed that total quality management in just-in-time lean and Kaizen are supported by the 5S principle and may be unattainable without them. While originally the concept is Japanese, the 5S principle have been adjusted in English-speaking context. 5S serve as a tool that is separated by TQM but can serve in entry point of TQM implementing in many organization. The 5S principle, short, Sherry, set in order, shine, sheso, standardize, shiketsu, and sustain, Sitsuki. Next is the flowchart. Actually, flowchart, all of us know what is flowchart is, but I will discuss to you what is the meaning of the symbols. Oval or rectangle with rounded ends is customarily used to denote the start or the finish of the process. Rectangle is the customarily used to denote the process step in activity and operation. It may represent the entire process, sub-process. Diamond is used for denote as decision point. These symbols, the hexagon, these symbols denotes preparation. The parallelogram denotes input or output. The symbol represents the commentary or the paper produced in required by the process. Circle is the use of connectors from one chart or page to another with numbers if necessary. Okay. The line is the R always indicates the path and direction of flow of the process. Actually, the flowchart use for quality tools because flowcharts help us to determine the what is the standard process of making of products like that. You need to flowchart to simplify to make the process more simple and be more visual.